Welcome to MyProjectBazaar.com. Our title is Aggressive Resource Provisioning for Ensuring Quality of Service in Virtualized Environment. And coming to our abstract, elasticity has now become an element feature of cloud computing as it enables the ability to dynamically add or remove virtual machine instances when workload is changes. However, effective visualized resource management is still one of the most challenging tasks when the workload of a service increases rapidly. Existing approach cannot respond to the growing performance requirement efficiently because of their inaccuracy of adaptation decision or the slow process of adjustment, both of which may result in insufficient resource provisioning. As a consequence, the quality of a service of a hosted application may degrade and service level objective SLO will be thus violated. In this paper, we introduce a SPRNT, a novel resource management framework to ensure a high quality of service in a cloud computing system. SPRNT utilizes an aggressive resource provisioning strategy which encourages SPRNT to substantially increase the resource allocation in each adaptation cycle when workload is increases. The strategy first provisions resources which are possibly more than actual demands and then reduces the over provisioned resources if needed. By applying the aggressive strategy, SPRNT can satisfy the increasing performance requirements in the first place of the quality of service can be kept at a high level. The experimental results shows that SPRNT achieves up to 7.7 speed up in adaptation time compared with existing efforts. By enabling quick adaptation, SPRNT limits the SLO violation rate up to 1.3% even when dealing with rapid increasing. This is our main flow of our project, in which first we have to create cloud parameters like a data center and a data broker, and we have to create the number of virtual machines. All these details are given to SPRNT system. The SPRNT system contains VM controller and SPRNT scheduler. VM controller that will controls and manage the creation of a virtual machine, and the scheduler will schedules the job to the end user, in which the scheduled jobs and all other informations are stored in the decision engine. The decision engine will decide uh, decide and schedule the jobs to a particular VM. Then finally the resources are allocated to the end user. By executing our project, this one is first frame, home frame. This one next frame, in which we have to create a data center. I have given a value 11, then clicking a create button. Now 11 data sets are created, in which there is a content like this: number of machines, host ID, and number of physical elements, and RAM, bandwidth for particular this data center. Like this, totally 11 data centers are created dynamically. And next frame, we have to create a data broker. The data broker is important to transfer the jobs between virtual machine and cloudlets. Cloudlets means cloud users. Here I am giving a value of 5. I have to create totally 5 number of data brokers. Here in which this one is a broker's ID and this broker's name and broker's ID. Broker ID will generate randomly. This also dynamically create based on our given value. And then next frame, we are going to create a virtual number of virtual machines. Here I am going to create 22 number of virtual machines. If I create once I create a virtual number of virtual machines, that details of a virtual machines are given to the particular data center and particular VM ID, in which VM ID in zero ID is given to the third ID broker ID. MIPS is physical elements. MIPS are RAM and bandwidths are all are physical element of the particular VM. Here I given a 22 input. So 22 VM virtual machines are created. Next frame, creating a cloudlets, in which cloudlets means number of users. I am giving 11 users. Here cloudlet ID are transferred to the broker ID. So the broker ID are going to transfer the cloudlets job to the virtual machine. So zeroth cloudlets jobs are transferred to the sixth broker, and first cloudlets are transferred to the second broker. Here that's like all likewise all. And then there is a length and a file size, output size, that all are represents the parameters of a given job. Here I am going to get a total workload of the VM parameters. Here these are all but workload of a particular VM. Here I am going to calculate the total workloads. This one is a total workload. Then here I am going to getting a fitness values. This is a fitness value of a particular VMs, and this one is a parent ID. Here we are going to execute a genetic algorithm, so we have to create a parent, and then we have to cross over them to get a optimized population based on the maximum fitness value. These are all having a maximum fitness value. This one is a optimized result, that a particular VM's parameters are. Then these VMs are give optimized results. We are going to give a job to these optimized virtual machines. Thank you.